Hey everyone, and welcome. Today we're going to break down one of the most fundamental ideas in all of cybersecurity, signature-based detection. It's kind of the OG, the classic way we've always taught our computers to spot danger. All right, let's get into it.
So let's just start with the biggest question right up front. How does any piece of software, say your antivirus program, actually know it's looking at something malicious? I mean, how does it tell the difference between a dangerous virus and your vacation photos?
Well, the answer comes down to one key word, signature. Now, think of a signature like a digital fingerprint, or maybe even better, a wanted poster. It's a very specific, unique pattern of data that security researchers have already identified and said, yep, this right here, this is a bad guy.
And the process for using these signatures is honestly incredibly simple. The security software just takes whatever it's looking at, a file, an email, some network traffic, and it compares it against this huge library of wanted posters. If it finds a match, boom, the alarm bells go off. It's really just a high-tech game of matching.
Okay, so let's get practical. How does this most wanted list actually work in the real world? What do these signatures even look like? Let's use a classic example that I'm pretty sure we've all seen in one form or another. A nasty email trying to trick you into opening up something you definitely shouldn't. Now, here's where it gets interesting. A signature often isn't just one single thing. It's usually a combination of things that have to be true at the same time. So in this case, the signature might be built to look for an email where the subject line is exactly free pictures and the attachment is named exactly freepics.exe. It needs both. So when an email comes into your inbox that checks both of those boxes, bam, the system flags it. It's a perfect match for a known threat, and it gets shut down. A clear, easy win for the good guys. But don't think signatures are just for emails, not by a long shot. A signature could be looking for a network login attempt with the username root, which is often a big no-no. Or it could be a really specific error code in a log file, like status code 645, which can mean something sneaky is happening. At the end of the day, pretty much any digital pattern that consistently spells trouble can be turned into a signature. And this is the most important thing to remember about this whole approach. For the threats we already know about, the ones we've seen in the wild, studied and fingerprinted, this method is fantastic. It's super fast, really efficient, and it's incredibly good at catching the usual suspects. But here's the million-dollar question. What happens when the bad guys are just a little bit clever? What if they know we're looking for that exact pattern and they change it? Just a tiny bit. And this, right here, brings us to the major blind spots of this entire system, because sometimes a really small change can make a huge, huge difference. I mean, just look at this. It's so simple, it's kind of scary. The attacker takes the exact same malicious program, but instead of calling it freepics.exe, they just added 2 at the end. The dangerous code inside is identical, but the name, the thing the signature is looking for, is now different. And because our system is so literal, it's only looking for a perfect match. It sees freepix2.exe, compares it to its wanted poster for freepix.exe, and goes, nope, not a match. And just like that, the threat sails right past our defenses. And this one problem points to a whole bunch of other critical weaknesses. For one, this method is totally useless against brand new, what we call zero-day attacks that nobody's ever seen before, because there's no signature yet. It also has no way to understand context. It can't tell if a request and a response are related. And it has zero memory, so it can't spot a slow and low attack that happens in little steps over hours or days. It only sees the one thing that's right in front of its face, right now. Now, after all that, you might be thinking, this system is kind of useless, right? But that couldn't be further from the truth. It's much better to think of it as a foundational first step. It's simple, it's fast, and it is absolutely still essential. So let's look at the final scorecard here. In the strengths column, it's simple, it's fast, and it doesn't bog down your computer. It's fantastic for knocking out the massive amounts of common, known junk out there. But in the weaknesses column, well, it's blind to anything new, it's easily tricked by tiny changes, and it doesn't understand context or have any memory. And that's really the ultimate takeaway. Signature-based detection is like the big, strong front door lock on your security system. It's an absolutely essential first line of defense that stops a ton of problems. But because of its blind spots, it can never, ever be your only line of defense. Which, of course, leaves us with a really important question moving forward. If signatures are all about catching the bad guys we can already pick out of a lineup, then how in the world do we catch the brand new ones, the threats that no one has ever seen before? And that, well, that is a story for another time.